Okay, so thanks, Henrik, for the introduction. I don't have anything fancy like Jonathan as the background image, right? So what I can do is, I don't know if you see that. So that's a small sticker here. So it's a pleasure to be part of that virtual conference here. So more or less, Andy pushed me a bit about that. So he said, "Wow, there's a great event going on soon, and you do not have to travel and so on." So it's a lot of interesting stuff you could most like to present there. So a perfect fit. I'm happy to be here. Credits go also to Andy, of course. So he's very, very well known in the EPM space. So myself, I'm the cluster performance engineering lead. So I'm calling it cluster performance engineering experience here. So we are a very, very small team. So the content you will see here is basically handled by 2.5 full-time equivalent here. So we move a lot of things here with very few people here regarding performance validation, performance testing. So that's the topic today. So so the agenda for today. So what I want to talk about is just very quick. So who is Dynatrace today? A few people of you probably know Dynatrace, so I'm not going into detail here, but it's a bit about of our digital transformation, of our own digital transformation. The second thing here is really about the continuous delivery and feedback pipeline. So this is really our heart of everything we are doing here. So I think that's really critical to mention here. And then we go a bit into the details about what my team, or what really 2.5 full-time equivalents, are doing on a daily basis. So how do we test such a distributed environment as Dynatrace is right now? So we talk a bit about continuous validation. I'll give you a few examples here on what we did detect and why we did it detected and so on. So a bit on the toolbox. So what tools we are using right now for testing. It's not that obvious. Another thing is that's very important from my perspective is it's not only about our own code. So our own code is important as well, of course, but we also are using, like you as well, most likely, third-party components, be it a data store backend or something like that. So they do have a very important role for us and also for quality, of course. Then a few lessons learned in the QA section at the end. So I hope this agenda looks interesting to you. So the first thing is really about Dynatrace. So, Dynatrace was founded 2005. So, most likely, let's say the old Dynatrace product. So the Dynatrace Admon, how is it called now? Very pure path centric view and so on. So, but a few years ago, we also determined that we need to shift somehow. So we also gone through a major transformation in the last year. So a few numbers here. So we got more agile. So we have an agile development process with sprint 2-weekly sprints. So if you commit a lot of story points, so the main difference to our past is really that while we had 2 releases per year in the past, we now have 26, or every 2 weeks we are releasing something to production. So that's a major shift in what is needed then actually regarding testing and so on. So hopefully, and we are sure, we are providing more quality right now. So with a lot of automated unit tests, integration tests, low unit tests, whatever it needs to be executed in an automated way to basically get nothing serious out into production which may hurt us. So we do find a lot of production bugs. Production bugs not in a sense that all are found in production, but really critical bugs which we cannot go out into production by development, so by engineering with our 3 stages or our 2 pre-production stages we have, which I'll show you later on. So, and more stability. So we have a lot of machines. We have built the new architecture in the sense that it is scalable, fault resistance, and so on. So really, that was even for us a huge change in the mindset, a huge change in efforts and thinking and so on. So yeah, we are really proud of that. So but Dynatrace in the new architecture is more or less available in two flavors, right? So the one is our SaaS offering, so everything running in AWS, hosted in AWS, and allowing customers and trials to be registered there and using our shared environments there. And the second one is Dynatrace Managed, how we call it. So it's an on-premise solution. So if you do not want to give your data out, so monitoring data out of your company, you also are able to install Dynatrace Managed locally in your data center. So the privacy aspect here is a very, very critical one. So if we have a quick look on the architecture, what you see here is the Dynatrace Managed architecture, so that the second flavor from the previous slide. So what we have here is some kind of scalable grid architecture we have with one-to-many nodes we can spin up with for a Dynatrace Managed cluster. And having a look on what contains on a single node is Nginx. It's a Java process we call security gateway. We have the server, our own server process, receiving and processing transactional data, pure path data, and so on. And we have a few like Cassandra as a database backend, Elasticsearch. So a few components involved here per node. What we additionally have to, as the name says, manage. So more or less we manage remotely those kind of clusters out there at the customer if they allow us to do so. So that's the one thing. So we have something built which is called mission control. So where we schedule cluster updates remotely in an automated way, so without any user interaction. We do have proactive support, so we're proactively looking at things, of course, licensing and all those kind of subcomponents here. That's a Dynatrace Managed architecture, so more or less everything on a single node. So one isolated node is more or less self-containing. There is a difference to SaaS. I do not have a slide prepared for that, but more or less this means in our SaaS offering, so hosting in AWS, we have per component. So our server component is then running on a dedicated machine. Cassandra is running on a dedicated machine. So that's the main difference regarding the managed and the SaaS architecture. So if we have a look on some kind of real world deployments or a real customer, and you go into a very prominent screen called Smartscape in Dynatrace, you see, for instance, the topological model, right? So which hosts, which processes, services, applications, and data centers are monitored, and especially the interconnectivity between services and processes are visualized here. And a few red nodes here are more or less highlighted because our AI problem detection engine detected something is wrong there. So looks quite interesting. So if you deployment statistic for this particular customer, so it's a 3-node managed cluster, so nothing fancy in a sense that is, let's say, we need over 100 nodes or something like that. So it's a 3-node managed cluster with 3 capable machines. And the customer has deployed around 25,000 agents here in production. And we are quite safe here regarding CPU utilization, for instance. So that's just an example here. Okay, the second thing is our continuous delivery and feedback pipeline. So this is something really very, very important for us. So we have 3 stages here. So the first one on the left-hand side is the dev stage. So here is basically the daily engineering happening. So we are developing things, fixing things, automated execution of unit test, integration test, builds are created and are automatically deployed into our dev clusters. And we also have acceptance testing there. So more or less all engineers, for instance, in sprint review meetings and so on, all engineers are more or less customers of those dev clusters here. And of course, performance and load test is important there as well. And the second one is the acceptance stage. So we get, while we have daily builds automated deployed in the dev stage, we more have daily deployments in the acceptance stage. So the main thing here is the acceptance stage is, testing the end-to-end user experience here. So a few people here working on trying new things out, and if it is all okay. So it's not, there's not developing here anymore happening. So it's more like fixing things, backporting bugs, backporting fixes of bugs, of course, into Git branches and so on. So that's the second one. So those 2 dev and acceptance are 2 pre-production stages. Again, a lot of automation here. So cluster update and deployments are automated and so on. And the third one, of course, which is the stage important for our customers, obviously, is, again, we do, before going something into production, from the acceptance into production, we execute additional tests and so on. We deploy things then in a controlled way. We monitor that, of course. And of course, we also have seen things like going wrong, of course. So that's the real world. And we need some kind of hot fixing. So what we have, especially for the production stage, is something we call fast lane to production. So if something goes wrong, the infrastructure and the build infrastructure is somehow higher prioritized. So if something goes wrong and we have to roll out a fix rather quickly as we have identified a problem. So we're gonna do a hot fixing here, doing automated tests and then deploy, and we are hopefully safe again here, just in case if there's popping up an emergency which needs a code fix. Okay, so that's a bit about generally, Dynatrace, our digital transformation, our CDF pipeline, and so on. So get a bit more into detail on the topic today. So what I want to start is to give you a bit on a comparison what it means here, local development versus large-scale production. So local development does not look like that every day. So if you are in the right team here and you have nice team colleagues and so on, and you go to honeymoon, you may end up with a workplace, something like that. So some crash, and a few days later, it might then look like that. So a big surprise, right? If you return. So funny things. So getting more seriously, a typical local dev setup is quite capable these days, of course. So computing power, SSD, a lot of RAM and so on. But the main difference here is really about local and large scale. Is on a local machine, of course, you have a single server component. So servers are our main Java process. You also have a single Cassandra, Elastic. So more or less not distributed at all locally, no network latency, of course. By default, you have 5 tenants. So a tenant is more or less a separated environment. So you can say that one tenant is equal to a customer, for instance, in production then. So really separated environments shared on a single server, for instance. And if the local engineer goes that far and even installs, for instance, a real Dynatrace one agent then, and then some kind of easy travel demo application we have, we locally more have 11 agents of different types. So an OS agent sending host metrics, a Java agent, and Apache agent sending process-specific metrics. So locally, if you open Smartscape, it looks a bit different, right? So what we have seen before, so a single host, a few processes, services, and so a few nodes, everything is fine locally. So small scale perfectly, right? So if you add something to the Smartscape URI here, so the team is adding something, and usually locally is everything is fine. So how about large scale production? If we have a look on a single SaaS cluster here, so hosted in AWS, so a single one means we have currently around 20. So this is one of them. We have a few machines here per component. So we have, for instance, 4 security gateways as some kind of entry point for our agents running at the customer. So 4 server nodes processing the data and the database backend for different purposes. So Cassandra and Elastic also distributed among different nodes here. So what we have here is such a cluster, a single cluster can host 1,000 plus tenants, so more or less 1,000 customers. We have productions out there with 20K or plus agents there. So with a few machines, so those are AWS machines of this kind of instance type. So commodity hardware, for instance, on a Cassandra Elasticsearch, so nothing fancy, nothing really large. So we still have room here, scaling up, scaling out. So the architecture is basically built on that, supporting that. So of course, also, I mean, a different here is network latency. So everything is distributed then in large scale production and so on. So a lot of difference. So if we have a look on Smartscape in the very early days, so let's say 3 or 4 years ago when we go live, a single customer looked like that. So the screen is a bit old already. We evolved over time a lot here, but yeah, it looks a bit fancy as well. But in the early days, it really brought us into troubles on the server side. So close, to be honest, so close getting down even. So this was some kind of, it looked from a layouting perspective, it looks like a Death Star. So it's still some kind of running gag. So that Smartscape in the early days with the layouting, it somehow looked like the Death Star of Star Wars. Another area is the visual resolution path, for instance. So again, in the very early days, we even can or did paint mushrooms. So those area in Dynatrace was and still is the way to how a problem. So our AI engine, if it detects a problem, the visual resolution path UI basically allows you to, how did the problem evolve over time? So which entities, which services, and so on have been involved in the problem over time. So very impressive as well. Looking impressive somehow. Is it really useful from an end user perspective? Hardly, because I mean, you most likely cannot see anything anymore. And did it cause cluster stability issues? Yeah, definitely. I can underline that. So again, the thing was really about priorities, so what we did and we have learned from, to be honest. So we have certain features have not been built for large scale from the beginning. And the other thing was really that at that early time, we did not have a dedicated continuous load testing in place. So that was really the thing, what was very crucial for us in the early days. So talking a bit about, I call it key performance influencers here. So we have a few variables here affecting us negatively. So, or can affect us negatively. So it's the number of servers with all the distribution and distributed on-demand analysis going on. Of course, also the number of tenants. So we have heard 1,000 tenants plus. So we have around 40 plus periodic workers per tenant. So if we do some math here, we end up in a 4-server environment with around 160,000 periodic workers in a single cluster here. So a single periodic worker from a customer, from a tenant, may go crazy if something goes wrong, and even affects other customers. So this is a very crucial one here. Of course, the number of agents, the number of, or the kind of topology models. So what is the number of monitored host processes, service application, and so on. Of course, the number of time series data the agent from the customer side is sending to our clusters. So a lot of things here going on, which might affect us negatively. Of course, also UI requests, and it's not always the number of UI requests, also the type of. So we have UI requests which are more expensive to deal with on the cluster side. We have others which are more Cassandra bound, for instance. So a few influences here to keep in mind. So the question here is really now, so how do we ensure throughput? How do we ensure scalability? And how do we ensure quality with around 40 plus engineering teams working on the product on a daily basis? And we are releasing every 2 weeks something production ready into our SaaS offering, and every 4 weeks into our managed customers. So that's the big challenge here. And from our perspective, and we have learned it that way, it's really the continuous thing. So continuous cluster performance validation 24/7. So it's not about testing a few hours before we 24/7. Okay, if we have a few scenarios here. So 2 of them, both for the SaaS offering. So we have a daily regression. So daily regression is a small cluster, not distributed among components, really to detect on a daily basis things. So with Git master builds. And we have a second one where we are testing sprint builds. So if a sprint ends, we publish those sprint builds, which should be more likely stable because they have been running for 2 weeks in dev environments before. And those testing and those test runs are running on production-like infrastructure. So an equally equipped cluster here from an infrastructure point of view, equally costly, of course, but absolutely mandatory. So having a look on the daily regression thing. So what the goal here is really, as said, we want to achieve a daily regression feedback on Git master builds. So what we do here is that's a screen from our orchestration layer, so which is automatically updating our clusters on a daily basis, including the load testing cluster here. So on a daily basis, we get a new cluster build, and the nice thing is that with this approach, we do not only test the cluster, but also the orchestration layer. So for deploying new cluster builds in dev and sprint stages, we use the same mechanism as in production. So a few numbers here. So for the small environments, we have split up a few tenants here. So in production speak, a tenant would be a customer again. So we have a few simulated tenants here with a different number of connected agents, for instance, per tenant. So we are simulating a larger tenant, a smaller tenant, a mid-sized tenant, and so on. So that's more or less the goal. A few server utilization patterns. So of course, I mean host CPU, but then there's also the load per minute. So something we call service calls. So that's similar to pew paths, which you might know from the early Dynatrace days. So and of course the number of agents of different types, again simulated here. So every weekday in the morning, as we are still in daily regression, so daily builds, every week in the morning we get an exhaustive breakfast, fruits every day, cheese not every day, but still nice. And what we do is, most seriously, daily regression is really daily validation. So if example here, so if a component here shows from one day to another day with the same attached load, a different performance signature. So for instance, the response time of something went up around 50% relatively. There's obviously something wrong if we didn't change anything regarding the attached load, which we do not do usually. So it needs to be some kind of regression in the cluster. So what we have here is we built something on a daily basis here again that we more or less get some daily averages across several metrics, across our several components. So for Cassandra, for Elastic, how are they utilized from yesterday to today, for our server, for our security gateway, and so on. So a lot of things going on here to basically allow us to charge in the morning when entering the things. How did we went from yesterday to today with the same load but a new cluster build? So that's the main purpose here. So we are doing it that way, that our load test environments are all monitored by Dynatrace, and by using the time series export API, we query stuff, right? So for a constant time frame, the same time frame every day, so we really have the same time window covered here, and all automated. So everything you see here is really all automated. So entering the office, and we have the metrics available for the last run. But what we still do is the approval or rejection of a daily build is more or less manual, because it needs some experience, and we still want to have a look on all those kind of things. If it is worth to create a Jira ticket to talk to other teams and so on. So that's a manual step, but everything else before is manually, is automatically. So one thing is really important is that for doing daily regression or regression testing is really that we need a deterministic unchanged load. So for instance, the highlighted things here, we have around 2,600 simulated agents every day attached to the daily cluster here, with more or less equal the number of service calls per minute every day. So that's important, because I mean, if you change something in incoming load, most likely, for instance, host CPU will change as well, positively. So a few other examples here which might not be that interesting. So let's talk about a few regression examples. So this is one we also have seen. So then it's about analyzing things, right? So we have more or less 24 hours worth of check-ins, so of engineering work. We have our monitoring tools and so on. So we are pretty good in things, identifying things, what might have really affecting something. So of course, in Git log, so we can identify the component and then go to Git log, for instance, so what had changed, talk to the responsible teams and so on. Identifying things and, for instance, not improving in the first place, but for instance, reverting. So if a revert of something really brings us down again to a previous level, so I think we are pretty clear that is the effect. Usually reverting means reverting a feature. So it's not the final solution, but we at least know which kind of optimization we need to take at. Another one, it's not about response time, but CPU consumption. So again, a very crucial component in the server process. So from one day to another, we see around doubling or even a third time an increase of CPU consumption of a single component. So this is also something which ideally we detect on a daily basis. All right, sprint builds. As said, sprint builds are tested on production-like infrastructure. So the goal here is really validating more or less sprint builds which should be stable in a large-scale fashion. Again, 24/7. So it's not about testing a few hours and we are gone. So it's really about having that running all the time. It's about regression, of course, stability, feature test driving of new things, large scale, and a very important one for us because it defines the downtime. So SLA agreements is really, do we still are able to do rolling cluster updates at full load without troubles. So, not or stopping every JVM and so on and deploying a new build, but it's really, for instance, one so each other. So in a rolling fashion, are we still able to do that at full load, for instance? We do not do automatic updates here for a good reason, because one reason is really that things might go wrong after 24 hours. So I'm pretty sure you're familiar with memory leaks and so on. So we have seen things like going wrong or memory leaks getting here after 3 days or something like that. So that there's a good reason to not automatically update that large scale environment on a daily basis. So talking a bit about the deployment timeline is really, so if sprint 82 is, for instance, in engineering, so 2 weeks, we are still on sprint 81 in load testing. Then we have some kind of final weekend run from Friday to Monday, still on the older sprint builds, even if sprint 82 is already finished from an engineering perspective. And then we give on Monday, Tuesday production go, no go. And then we again switch and update in a rolling fashion here to the next sprint build. So that's more or less the timeline. As sprint builds, as we are running on different hardware, so production like hardware, we also can simulate or run, of course, more loads. So 1,500 tenants, for instance, and 30K agents simulated. So always higher than in production. So that's the important thing here. And again, shifting connected agent, for instance, simulating a single large tenant, for instance, and smaller ones and so on. So more or less what we also see in real life. The thing is that we also see regressions in large scale first. So we have things which we did not see in daily regression because the load is too small. So what we also see is, first thing, for instance, doubling the GC time of our server component when switching from sprint X to X plus 1, which was not visible in daily regression. So another thing where we really need testing on production-like infrastructure on the same hardware, even if it is equally costly. Okay, a bit on the toolbox we are using. Unfortunately, we cannot use common load generator tools like NeoLoad and Gmeter, for instance. So we have very specific requirements for a load generator because we more or less need simulating real agents, right? So what we have is we built something we call cluster workload simulator on our own. So it's a proprietary tool simulating real world agents, sending data to the cluster, and for instance, with a single CWS JVM configured in a way, what we see here, we, for instance, can simulate close to 16,000 agents in a single CWS JVM, for instance. So testing large scale, a high number of agents, that's the only way to go to have something in place here regarding load generator. Of course, Dynatrace, so we are eating our own food, ideally, of course. So we have our daily validation environment, of course. So for the daily regression environment, and well, common tools, right? Like for heap dump analysis, Eclipse, for instance, there are others out there as well. Thread dump analysis, plugin or something else. So a pretty common performance engineering tool set beside the cluster workload simulator, most likely. What we also use from time to time is Java flight recording, so very useful profiling built into the JVM. So mainly we are using that for object churn topics. So how does the allocation rate look like for particular components, for instance, in the server process, and also for thread log contention analysis. So a few JVM options here, for instance, we are using. So this ends up in taking an automatic 1-hour GVR session after 6-hour JVM uptime. So nothing manually to do here to start something. So when the JVM is uptime for 6 hours, the JVM automatically creates a 1-hour GVR session on a daily basis, for instance, in the daily regression environment, which means that you see, for instance, one flight recording file per day automatically created. So if we really enter the room and we are not able to analyze it, for instance, with Dynatrace, for instance, object churn related stuff, we are still capable to do some eye matching before after analysis, for instance, with flight recording files created in an automatic way. We are using it also for optimization. So for our AI engine, a very crucial central component, where identified a very high object churn here. So the first thing is identifying, right? And the second one is then trying to fix it. The fix was rather easy in this particular example. So 20% less object churn meant the factor of 2 in throughput increase. So for a very central component, and a great effort here. And other things, I think you're aware anyway, so GC logs and so on. All right, so to sum up a bit, so that's all about our own code, right? But we also use third-party components, and I do not want to, to bash at that product or something like that, but I really would like to highlight them as equally important or even evil. So a few examples here, if you don't mind. So for instance, a large scale with Cassandra, we are very happy with Cassandra being extremely robust for us and so on, but still we need to be careful when switching versions, for instance. So this is a test we have been doing large scale in the sprint load testing environment with 9 Cassandra nodes. So really without changing any load infrastructure and so on. So really the same infrastructure, same incoming load, just replacing or updating Cassandra to a new version. And gave us chart-wise a big surprise, to be honest. So increased CPU, most likely or for sure related to doubling GC time in the Cassandra JVM. So that's one. We opened a ticket for that, for instance. So we identified that. So that more or less was then fixed in 3.11, for instance. So we pushed out something into load test here as well. And whoops, what happened here, for instance? Well, the blue line is heap utilization. And you see that over 3 or 4 days or something like that, we see a memory leak. So again, something opened the ticket. So important to test third-party components, large scale as well. Another example is that we are using Chatty as embedded web server. So switching to 9.4 was a big thing regarding throughput. So a lot of things changed here positively. But what we did see then was a big surprise as well, because we see a huge difference here in minor versions, so 9.4.7 versus 8. So what you see here is 3 nodes, 2 nodes with .8, 1 node with .7, keep it running a few hours or even days. And what we see is really a completely different picture regarding GC suspension across those 3 instances. So again, more or less looks like, and it is a memory leak. So be careful here as well. So a few things I would like to summarize. So what we really learned was that not all features were built for large scale from the beginning. So it was about priorities, features. It's always a bit on, features versus quality from priority and resource perspective. We had no dedicated continuous load testing from the beginning, so it was more like, okay, we should most likely do some load testing and then we switch over to features again and so on. So no dedicated thing here. So for us, since 3 years, it's really about, so 24/7 cluster performance validation is really a no-brainer for us. And it's an absolutely must-have investment for our agile 2-weekly release cycle, pushing something into production, into close to 20 SaaS clusters and a lot of managed clusters out there with good quality. So one thing with testing is, of course, always that test coverage, and we are simulating things, so not real agents, but simulated agent which more or less behave like real agent, but still, it's not the real world. So with all the pre-production stages we have, dev, acceptance, load testing, and we still see certain issues in production the first time. So I mean that's real world, and it's really how to react on that. So what we do, or what also the performance engineering team is doing together with DevOps, for instance, really proactively investigate production, not at that point when already something went wrong. It's usually late. But for instance, if we see some uncertain or weird CPU patterns, for instance, then we do some deep dive analysis beforehand here already, before something really something bad happens here. Okay, and a few things here. It's not only our code. We have a lot of code, of course. It's also third-party components, so they're very useful and so on. But still, stability, large scale is always an issue here as well. What we want to do is really to invest in Chaos Monkey. So Chaos Monkey is, I mean, the term which most likely everybody knows. What I really like a bit more is the term destructive engineering. So really looking for people which are, their destructive talents on a daily basis, and, kill nodes, kill Cassandra, simulate an entire AWS availability zone outage, for instance. So a lot of things, keep people destroying things, not by accident, but for sure. So one thing is really that it's the toolbox is not only about load testing. So all engineers can do that. So if they add something in the UI, for instance, and want to see how does my UI behave with, let's say, 1,000 host entities, so 1,000 OS agents, that's something which can be simulated locally as well. We do not need load testing for that. And in a very small team with 2.5 full-time equivalents working on that topic, it's all about automation. It's very, very important for us, automation, and APIs. So, the one example here with the time series export API, for instance, we have others as well. So it's really about APIs, not only in the Dynatrace product, but across all tools we are using in our CDF pipeline, for instance. Okay, before going into QA, to close up a last slide here. Sorry, Henrik. So, I mean, regarding performance engineering, from my perspective, it's not only about, load testing. And so it's also about how do we behave if something goes wrong. And I think that is my friend Ducky. So Ducky is something I really put on my door at the office, and reminds me every day on how to react on things if something goes wrong. So it's like a duck usually, it's always behave like a duck. I mean, keep calm and unruffled on the surface. So that's the head. So it's a matter on how you approach other teams and so on. But still be in move every time. So try to find things, analyze things, talk to teams to more or less improve the product. So, okay. So Q&A.
All right, Thomas, thanks for the awesome presentation. So I have from my end questions. I will also enable the webcam of Bruno, and I can see that we have also Stein connected. So I don't know if Stein was muted. Oh. So Bruno, I think you have a speaker enabled, so you have a lot of echo. So I'm just disabling your microphone. Let us know if you have any questions. And I will also enable Bruno, the other Bruno of the team, so we can also ask questions. All right. So I think Bruno, it's quite noisy. I'm just going to disable your microphone. up here it is. So my first question is it's just a note. So I can see that Thomas, you have helped Cassandra to validate the release. I guess you are doing some consulting services for Cassandra. So I didn't know that Dynatrace was doing this. That was a quite quite interesting experience to see that they were bringing a lot of impact to your environment. And by the way, you mentioned Cassandra, but did you have any bad experience with the meltdown patch that Intel was providing a couple of what was it, 6 months, 9 months ago, with the patch on the CPU level? Did you have any impact on your the behavior of the clusters and the environment by implementing the patch?
Definitely. I mean, I think I really remember on that. So it was around in January 9 or 12 or something like that, where we obviously see or saw, especially on the Cassandra side, not on the server side, but especially on the machines on the Cassandra side, more or less doubling the CPU, and in AWS. So, I mean, that was I think Monday entering the office and, having a look on the production charts from the weekend and so on, and whoops. So, so the matter was really what was going on here, and, contacting AWS support, and it was pretty clear, obvious then that something went wrong here regarding, applying some kind of hypervisor updates or whatever. So yeah, we definitely, especially on the Cassandra side, we really have been hit by that. So if we didn't, we found a pretty good solution, and I think AWS more or less improved that rather quickly. So, but if we would have run that way weeks, for instance, we really would have need to scale out or scale up. So really to do something on that, because the CPU level at that point in time was not in green anymore. So yeah.
Okay. And another thing is you mentioned the your testing solution that you're using for the testing the clusters, and it's just it's aligned with the conversation that we had previously with Jonathan. So I guess these testing solutions, you need relevant data sets because agents sends different type of packets, different type of data, and I guess the way you're processing the data that is sent by the agents in Dynatrace is basically will be totally different. So do you have also a sort of testing data as a code also approach internally? So you make sure that the data that you're pushing from those fake agents, they are relevant and representative for your within your production environment, or how do you do that?
Yeah, so it's simulated data. So it's not capturing production data and then reapplying in load test. So this is not what we are doing. So what we are doing is that a simulated agent from a communication perspective really acts like a real agent. So the communication channel from the simulated agent to the cluster is not something which is, for instance, faked or using a REST API to send data. So it's really the communication channel into the cluster, which is also the real agent. So that's one of the important things here. The other one is that we more or less have on a weekly basis, we have a look on production on, how does the data look like, or the factor of OS agents versus special agents. So there are a few things here which we have a look periodically, and we try. It's not always easy, and we are not always, let's say, that way successful, but we are trying to be close as possible to production here.
And also something that I think you didn't, it's not part of your current tests, but I know that you're adding more and more the time series API allow us to push metrics to take advantage of the time series API. So we are not sending the request to the same nodes as the end users. And I think with the DevOps trend, the fact that Dynatrace is going to be more and more plugged in an entire tool chain with the help of the APIs. Are you going to add more test cases to also add this traffic that could be growing in the next coming month on this API layer?
Yeah, yeah. So it's for instance the IoT, so custom devices, so the API we have for custom devices, for instance. So the customer is able for environments where we do not have a native agent, for instance, so not an agent install and so on for environments like a Raspberry, for instance, or whatever. So so what we provide here on the cluster side is some kind of time series import API. So our tool in daily regression is using the export API because we are interested in the metrics from our load test environment. But what we also have and do, and where we have to increase the test coverage, is really about the import API things. So pushing things into the cluster time series data, for instance, out of the scope of a real agent. Yeah, so definitely, yeah.
Okay. I have 2 questions from the audience, from the attendees. So the first one is, observe somewhat similar GC suspension as you showcased in your deck, where we saw high GC suspension time in Dynatrace, but the application response time from performance test tool as well as from Dynatrace was very low. I don't see the questions here. So yeah, maybe the name of the person that pushed that question is not there. So could you maybe more clearer on the questions, because obviously there is no clear question. So second question is it possible to have such a situation or something that Dynatrace team is looking to work upon on one of such cases? I think it's related to the GC stuff. That's the same. I think it's he posed 2 questions, but it was the same one. So do I need to rephrase? So observe somewhat similar GC suspension as you showcased in your deck, where we saw high GC suspension time in Dynatrace, but the application response time from performance test tool as well as from Dynatrace was very low. And the question is it possible to have such a situation or something that Dynatrace team is looking to work upon on one of such cases?
So you mean, I don't get the question not really clearly, I think. So does it mean that we involve other teams then on working on a solution then, or?
Yeah, probably bring that value into the product.
Yeah. So, okay. I don't know, to be honest.
Okay, so that will be more a question for your product management later on, I guess. All right, Wilson make a note about the patch. So that's not a questions by Wilson. Will be presenting tonight. I'm looking at. All right, so nothing, no on this. No questions. So I will ask Bruno De Silva, which is connected. I will just enable his. He's just enabled it. Bruno, do you have any questions for Thomas?
Hello, Rick. Hello, Thomas. Very interesting presentation.
Hi. Hello, Bruno.
I had one question about the when you check for the metrics before validating changes to production. Is it time consuming, and what do you specifically look for before validating?
No, it's not time consuming. So I mean, for the daily regression thing, we have a lot of automated here. So grabbing around 70 metrics across several components. So what we get on a daily basis is really, with some very lightweight change detection, for instance, we see that more or less 3 or 4 metrics come out here to have a closer look here, and so no, it's not time consuming. And before pushing something into production, we have 2 things here. So the one thing is really what our team is doing, so quality under load aspects, and the second one is another team covering is the acceptance thing, so the end-to-end user experience. So no, it's not time consuming and basically handled by 2 people. Yeah.
Okay, thank you.
I could have a question.
come on, Bruno, please. And
Okay.
it's I think we have a time for 2 more questions, and we will go for the next sessions of Bruno. Not
Okay.
you, Bruno, but the other Bruno I'm referring to.
Yeah, it's not a
Very
good idea
confusing.
to put both Bruno next one after one. But my question is, of course, to Thomas, and it's about the load model. So, because do you have different load model to test your tenant? Because probably your customer doesn't have the same behavior of architecture. So, what is how do you make your load model to test it?
There are more or less the simulated data we are generating of 2 different kinds. So the one thing is really time series data. So if we simulate an agent which send us an host entity, so simulated host, we also generate data like, host CPU, host memory, so time series data more or less. So we have a fixed set on time series metrics for infrastructure entities, for instance. So that's rather fixed, and it's not really different to what in production happens. So I mean, it's it's something we call a stat counter, so minimum, maximum, average, and so on of for instance host CPU and such metrics. The other thing is pure path, so transactional data. This is something we have modeled in a way that we are again trying to be close as production, with the death of the simulated tree, for instance, of a pure path, of the width, and so on. So what we are doing here is really having an average constant load all the time. What we have not automated yet is really, doing destructive things. So like corner cases, right? So for instance, spiking out any incoming traffic randomly or every day or something like that. So this is something we do from time to time manually, and this is something we have to do automated this year. So that's the plan.
Okay. Thanks, Thomas. So it's thanks for your really interesting presentation. It was really get the insights from how you're testing the infrastructure was really useful. I think for myself at least, but I hope that for the audience it was also useful.
I hope so.
Again, thanks again for being part of this virtual PAC and having your feedback and your testing process that you're doing is just awesome. So we'll be more than delighted to have you on the next physical event in January.
Okay, it was a pleasure. So thanks for inviting me.